Hello everyone, and welcome to today's lecture by Jagametrics. Today we are diving into stationarity testing and reporting. This is a subject that's not only fascinating but also incredibly relevant to econometrics modeling. Throughout this session, we will explore the two commonly used statistical tests for stationarity and the steps to execute them on the software package called Eviews, econometrics views. By the end, you walk away with 1. The purpose of stationarity, 2. The procedures for testing for stationarity on Eviews, and 3. How to report stationarity results. First, what is stationarity testing? Now, stationarity testing is a crucial step in time series analysis because many statistical models and methods assume that the underlying data is stationary. Stationarity testing is essential to ensure that your time series data meets the assumptions of the model and methods you plan to use. It helps avoid misleading results, improves forecasting accuracy, and ensures the validity of statistical inferences. Now we have two commonly used statistical tests for stationarity. They are the ADF test, augmented Fuller test, and the PP test, as the Phillips-Perron test. Now, the ADF test, the augmented Fuller test, the purpose of the test is to check for the presence of unit root in a time series. A unit root indicates that the series is not stationary, meaning its statistical properties like mean and variance change over time. The ADF test is an extension of the Fuller test and includes lag differences of the series to account for higher order autocorrelation. And the null hypothesis for the ADF test is that there is unit root, that is, the data is non-stationary. And the alternative test is that there is no unit root, means that data is what is stationary. And how do we go about it in Eviews? When we go to our Eviews platform, we click on File, we get our last work file, and we click on the variables, GDP for example. You click on View. And the first thing we do is to plot the graph of the variables. Plot the graph of the variable. Go to View. We click on Graph. Then we leave it at basic type, line and symbol, and click OK. And this is the graph of GDP. It shows that GDP trends upwards, fluctuates upwards from 1981 to 2023. And now, in order for us to conduct our ADF unit root test, we click on unit root test, standard unit root testing, and we click on, we have to select the test type. This time we're using the ADF and the Phillips-Perron. And for the ADF, we click on level, click on OK. Now when you look at the probability value of the t-tests of the ADF statistics, it is 0.9883. 0.9883. This shows probability value is greater than 0.05. Now when we go back to what we discussed earlier, we'll see that if the p-value is less than your choosing significance level, that is 0.05, you reject the null hypothesis and conclude that the series is stationary. Now for our GDP, the p-value of 0.9883 is greater than 0.05. So it means that GDP is not stationary. It's not stationary at the 5% level of significance. So we'll now go to let us look at the first difference of GDP. We click on unit root test, standard unit root test, and then we'll go to the first difference. Okay, good. Now at first difference, GDP is stationary. See why? Because the p-value of the t statistics is less than 0.05. It is 0.0175, which is less than 0.05. Hence, GDP is stationary at first difference. First difference, okay, we leave it this way. Okay, we go to GDP growth rate. The growth rate of GDP, let us see at what level is stationary for the ADF test. And go to, first of all, we graph the variable. We graph the GDP growth rate, and let's see how it's trending. Okay, this is the graph. You can always copy this graph and paste it on MS Word. Okay, this is the graph with different trends, both negative and positive. And so we'll now have to go again to the unit root test to test for stationarity. We click on levels again, click OK. So can you see that now the growth rate of GDP is stationary at level, because the probability value, which is 0.0243, is greater than 0.05. So GDP, the growth rate of GDP is stationary at levels. Okay, now let's go to the next variable. We look at government expenditure on social and community service. We also look at the graph. Let's graph the variable. Okay, click on graph and click OK. You can see the government expenditure on social and community service fluctuates upwards from 1981 down to 2023. And so we now move to test for stationarity. Click on unit root testing, go to standard unit root test, and then we click to find out at what point is stationary. For levels, okay, it is 1, which is greater than 0.05. Hence government expenditure on social and community service is not stationary at levels. So now look for go to the next level to determine stationarity at first difference. We click first difference, click OK. Even at first difference, the variable is not significant because the p-value 0.7774 is greater than 0.05. Okay, we now move to the third one. We now move to unit root test, standard unit root test, and see the second difference. Okay, click OK. Now we can see that at the second difference, government expenditure on social and community service is stationary at second difference. This is for the augmented Dickey-Fuller test. And now we will go to report them. We will go for the reporting. We scroll down to the table. Then we can see how the augmented Dickey-Fuller test comes out for GDP. Okay, let me correct this. For GDP at levels, it is 0.9883. At first difference, it is 0.0175. And the remark is that it is stationary at what? At first difference. Then for government expenditure on social and community service, at levels it is 1.00, which is not stationary. And first difference is 0.774, which is not stationary. And for second difference is 0.000, which is stationary at second difference. For the GDP growth rate, we also have 0.0243, which is stationary at level. So that is the reporting. So let us go and do the testing. Let us see the Phillips-Perron test. Now the Phillips-Perron test is another test for unit roots, similar to the ADF test. However, the Phillips-Perron test uses non-parametric methods to account for autocorrelation in the series, rather than adding lag differences. So it is often used as an alternative to the ADF test when there is uncertainty about the form of autocorrelation. Now, just like the ADF test, the null hypothesis is there is unit root, meaning data is not stationary, and the alternate hypothesis is there is no unit root as data is stationary. And it goes for the same interpretation. If the p-value is less than our choosing significance level, that's 0.05, we reject the null hypothesis and conclude that the series is stationary. Okay, we'll now go to Eviews and let us see the Phillips-Perron test for these three variables. First of all, we begin with GDP. We go to unit root test, standard unit root test. Then we have to change from augmented Fuller to Phillips-Perron. We click at levels and then we click OK. So just like that of ADF, the Phillips-Perron unit root test for GDP shows that GDP is not stationary at levels because the probability value of 0.9975 is greater than significance level of 0.05. So we'll now go and to the next level, the first differencing. Let's see if it will be stationary. First difference of the Phillips-Perron test. You see, so at first difference, using the Phillips-Perron unit root test for GDP, the probability value of 0.0241 is less than 0.05. Hence, we say that GDP is stationary at first difference under the BP test. Okay, so let us see that of GDP growth rate. Out of GDP growth rate, we'll move to view, go to stationarity, standard unit root test, then we click levels to see. Good. Now, just like the ADF test, the Phillips-Perron unit root test for the growth rate of GDP shows that GDP growth rate is stationary at levels, the same as that of ADF. You see, so we're done with that. So let us pick the other, the government expenditure on social and community service. Let us see. Okay, the unit root, go to unit root, standard unit root test. Okay, at levels for Phillips-Perron, let us see. Okay, it shows the probability value of 1, which is greater than 0.05, meaning it is not stationary at levels. Okay, let us do a first difference analysis of that. First difference. Okay, click OK. You see, at first difference, government expenditure on social and community service is stationary because the probability value of 0.0002 is less than 0.05, our choosing significance level. Okay, so now we'll go to the reporting section and let us see the difference. Now, if you observe of the variables tested for stationarity, government expenditure on social and community service is stationary at second difference for the ADF test, but it is stationary at first difference for the Phillips-Perron test. This is specimen 1. This is how you can report. You can report both two of them in the same table. And also, when you go down to specimen 2, this is how specimen 2, how you can also report your stationarity test. Now look at the note. Note ADF and PP values are probability values. They are probability values. Any values below the 0.05 is deemed stationary at that level, while any value above 0.05 is not stationary at that level of significance. So thank you very much for attending the class for today. See you some other time.